Okay, welcome back. Now we continue our studies with this notion of sequences with one concrete example. Okay, assume that you have some piece of bread, a loaf of bread, which you eat every half of it each day. What will happen to that piece of bread? We assume that piece of the bread is gonna stay healthy. It's not gonna change over time. Okay, because some people they might say, "Wow, what's gonna happen? Like 4, 5, 7 days gonna be like, I don't know, stale or something like that." But anyways, we assume that's gonna be good and great. Okay, so that we are interested in finding a model here, or a formula that would tell us about what's left of the bread. So in, let's say, day one. Okay, so uh, uh, you just have, you eat the half, you have one half. Okay, day two, you're gonna eat, you're gonna be, what's gonna left, it's one half divided by two, it's 1/4. Okay, day three, it's gonna be half of this one left, so it's 1/8. Day four, it's gonna be 1/16. Okay, day five, it's gonna be 1/32. Okay, and now we can see that we have 1/2 to the power n. Okay, let's check it. So day one, 1/2 to the power 1, it's 1/2. Day two, it's 1/2 to the power 2, it's 1/4. Day three, 1/2 to the power 3, 1/8. Day four, it's 2 to the power 4, it's 1/16. So we say that this is the general formula, the general term of our function. But our function in this case has a domain that's the set of natural number. So f is defined from n into r. Okay, if you have seen me defining f from n into n, that's a mistake or maybe misunderstanding of me. So it's from n to r. Okay, it can be n, it can be, but in general it's the set of the domain is the n or any part of n, subset of n, and the range is r or r in general. Okay, so in this case we have, for each n we have 1, 2 to the power n. Okay, we have a sequence. Why? Because the domain here is the set of natural number, and this f of n equals 1, 2 to the power n is denoted by u sub n. Okay, you can use it, but for sequences we use big letter indexed with some n or m. Most of the time is n. Okay, so we say that u to the u sub n is 1 to the power n. Okay, so this is our sequence in this case. Okay, so we have 1, 2, 1/2, 1/4, 1/8, 1/16, 1/32, and 1/64. And in general, we found the formula. It's on day n. It's what's gonna be left is 1/2 to the power n on day n. Okay. As time keeps moving, what's gonna happen? So this question here: what will happen to this piece of bread in the long run? That means the limit. This is asking us about the limit of un as n goes to infinity. So clearly we can use logic to get this one. So a piece of bread that you eat half of it every day, over and over again. Well, like assume like 1,000,000 days, what's gonna be left? It's some tiny, maybe tiny piece that you can even split. Okay, you can split it, but we have to split it mathematically, and it's close to 0. So that's why we say the limit of un when n goes to infinity is 0. We're gonna prove it later. We're gonna prove this one here. We're gonna prove that the limit of 1 to the power n as n goes to infinity is 0. We'll see how to define this one. How we gonna prove it? Okay, we're gonna use some simple logic and simple algebra to prove this result. But the idea is that the intuitive idea that you can feel, you can touch, you can see that clearly the limit is zero. You agree with me? If you don't agree, you're gonna say, okay, so it's not zero, it's 0.000000001. But this is zero for us. It's very tiny, small, very small. It's 1 over 10 to, let's say, 20. This is zero. It's clearly zero. Okay, it's not zero exactly, but it's zero. It's almost zero. Okay, so the limit here, but if you keep doing it over and again, you'll touch zero. Okay, so this is the concept that we need, and this is the notion that a sequence in general, in sequence, let's use un, is the general form, is a function that's defined from n or any subset of n into r. It's a function. Okay, so let's graph this one here. Let's graph this sequence here and see what we can get. Okay, so day 1 we have 1/2. So let's say, I'm gonna assume that this is 1. Okay, so day 2, day 3, day 4. So day 1 we have 1/2. Day 2 we have 1/4. Day 3 we have 1/8. Day 4 we have 1/16. Day 5 we have 1/32. So it's, so we can see here, it's just the points. We see that it's gonna keep going down. So it's a decreasing function, and we see that it's gonna approach zero. So this is zero. Yeah, so the limit is gonna approach zero. This is an intuitive idea. Okay, so graphing it would definitely help us, but in general we're not gonna graph any sequences. We're gonna see ways of finding the limits, and there are some ways that one needs to learn to get this idea through. Thank you very much.